Welcome back to part 2, where we have this 50 ohm RF digital attenuator all assembled in this little power supply box that was a former laptop power adapter. So the attenuator, as you may have seen in video 1, is this little one right here, and it is a PE4302 right here, and it has 6 inputs on this header for your 6 switches to give it attenuation from 0.5 to 16 dB. So we have 6 switches connected to this header, and we'll demonstrate that using the Nano VNA. So let's take a look at what's inside the box. So here we have the assembly inside the box here, and we'll take a look at where the attenuator is, a little module board right there. And you can see we put a little notch in the power supply box for the SMA connector to come through. And then on the other side, we remove the SMA connector from here and put some coax in to bring it to the panel, or the side panel right here. So that's the only modification that was made there to that little attenuator. And we have the header pins right here connected V1 through V6 to these switches, these 6 switches right here. And on the right side here is a LED light to indicate whether the power switch is turned on or off, and indicates also whether the battery has any voltage. Because these lithium-ion batteries, once they're exhausted, the voltage goes to 0 right away. So that would reflect, in the indication of this LED that it's time for a recharge of the battery, which is right here using this USB-C port. Since it is a 3-volt board, requires 3.0 volts, we had to reduce the battery voltage using this Zener diode and this 100 ohm resistor, so to give us 3.0 volts here. Now, as an alternative to using this 9-volt battery, you could use something like this 3-volt battery right here, which is a CR123A. They make them in rechargeable. They have a little USB port right here or at the end, and that would go right here in a little battery holder that they make for these, and that's would eliminate the need to have that Zener diode and that 100 ohm resistor. That's something to think about. So let's put it back together and in its case, and we'll put it on the Nano VNA, and we'll just see what happens here. So we'll be right back. There is no power yet, so this is what it looks like. It looks like we have a insertion loss of minus 12.8. We have a impedance of 60 ohms, and we have a frequency sweep of 500 kilohertz to looks like 60 megahertz. So let's take a look and see what happens when we turn this on and see what it does. Okay, it looks like it went to a minus 144 insertion loss, and that's in line with the specifications on this little digital chip here. So what we can do is normalize that minus 1.44 so that we can bring it up to the 0 dB line, and we'll normalize that by adding 1.45 to bring that line to 0. So let's do that right now. So there's your S21 offset, 0 dB, 1.45, and we'll enter that, and then it goes to 0. Okay, that's what we're looking like with the power turned on. No attenuation switches thrown yet. And we'll go ahead and let's start with minus 16, and we'll go down to 0.5 dB. So let's first watch minus 16. And there is the result, 15.86, and our impedance went down to 50 ohms. Let's turn on another switch. This will be 8 dB more for a total of 24 dB. And we have a reading of minus 23.8. Let's go for 4 more dB. and that is 28 dB of attenuation. The reading is 27.82, very close. And let's add two more. That's 30 with the 2 dB, and we have a reading of 29.84. Here we go with another 1 dB, and we have 30.8, and then a half dB more, and we have 31.33. So very close, and our impedance stayed pretty close to 50 ohms. So the one caveat I noticed about this is when you turn the power off, watch what happens. The power is now turned off. We start to lose attenuation. We're down to minus 19. And as it bleeds off, it'll even go less than 19. Let's see what happens here. And the reason why I say that's a caveat is if you have some sensitive equipment that you have between here and here, you may be overdriving your nano VNA, and we want to be careful we don't do that. So far we're down to minus 19. And if you needed more than that, if you needed 20 or 30 dB, depending on what kind of maybe amplifier you have, you may be overdriving the S21 port. So that's something to watch out for. Look, you can see it's still moving. After all this time, it's still moving. Minus 11. So we went from basically 32 dB down to minus 11 when the switch was turned off. And that would be the same thing as if you had a battery failure. So that's something to be aware of. Tune in next time for another project that we might put on the lab bench here. Thanks for watching.